All right. We are back for another Ohio State test review. Today we're talking about standard 8.EE.5. So a lot of this has to do with comparing rates of change and slopes and things like that. So let's hop right in. So a teacher compares the masses of two different samples of liquids. The equation m equals 0.674 V models the mass in grams of liquid ammonia. The variable V is the volume in milliliters. Okay? The graph shown below represents the relationship between mass and volume for hydrogen peroxide. So I'm going to make a note over here. I'm going to write the equation again. M equals 0.674 V. And what the question is asking us is to select words or phrases that complete the statement to describe which sample of liquid has a greater mass. So, your first choices are ammonia or hydrogen peroxide has a greater mass because it has the greater volume, unit rate, or initial value. So, we're given the unit rate for the ammonia. Okay, it's right here. Whenever you look at an equation like this, this is a linear equation written in the form of y equals mx plus b, where m represents your rate of change, and b represents your y-intercept, or in word problems, typically represents your starting value. The fact that we don't see a b in this equation means that our starting value is 0, which makes sense. Something with no volume has no mass. So we're looking at our rate of change of 0.674. Now we have to interpret our rate of change over the graph. So here's how you find a rate of change. You find 2 points. 0, 0 is a good point. A, because it makes life easy to work with, because it's 0 and 0. And B, you need to find a point where that's on an intersection perfectly, right? So the easiest one I can find is right here. This would be the point 90, 100. Could you go 90 to the right? I said 90 to the right and 100 up. Okay. And now we need to find our rate of change. The way that you find your rate of change is your rise over your run, or your change in y over your change in x. Okay? So comparing my 2 points of 0, 0 and 90 to 100. Okay? My change in y, I'm going from 0 to 100. So that would be a difference of 100. My change in x, I'm going from 0 to 90, so that would be a difference of 90. Okay? And now I could go into my calculator and I could do 100 divided by 90, and that would give me 1.1111111, repeating 1. Okay? So if I were to write an equation for this, our y-intercept is still at 0. So for my hydrogen peroxide, which I'm just going to put peroxide, my equation would be m equals 1.11 V. So now the question comes down to which has a greater mass. And the greater mass would be the hydrogen peroxide, as 1.11 is bigger than 0.674. As for y, it's because it has the greater unit rate, or slope, or rate of change, or any of the math buzzwords we love to use. Okay? So that's question 1. Going to question 2. 2 companies manufacture pens. The number of pens Y company Q produces in X hours can be modeled by the equation shown. The number of pens company R produces per hour can be modeled by the graph shown. Based on the models, what is the difference between the number of pens company Q produces in 8 hours and the number of pens company R produces in 8 hours? Okay, so let's do this first. We know that hours is represented by X. Okay, so let's just get company Q out of the way. If company Q is producing in 8 hours, that means we're going to take out X and we're going to plug in 8. And whenever I substitute, I always use parentheses to make mathematical errors less common. So we'll do 250 parentheses 8, put it right into your calculator, and it's going to tell you that in 8 hours, company Q is going to produce 2,000 pens. Okay? Now let's look at company R. Company R, we have to do the same thing. The same thing. Okay? But we got to do the same thing that we did in the first problem, but they're nice enough to give us the point. This point is 3, 600. I know this is 3 because it is, clearly counting by 2's here. To 4, the number between 4 is 3. Between 2 and 4 is 3. So we're going to do our rise over our run again. And it's convenient because we're once again working with 0, 0. Okay. So our rise, our change in Y, goes from 0 to 600. So that's a difference of 600. Our change in X goes from 0 to 3. So that's a difference of 3. Which means our rate of change is 200. So if we wanted to write this, we write Y equals 200X. That's our equation. Okay. So now we're trying to figure out how many we produce in 8 hours. So we're going to do the same thing we did for company Q. We're going to take out X and we're going to put in 8. And we're going to go to our calculator and we're going to go 800 or 200. Whoa, 200 parentheses 8. And that'll give us 1,600. So now it says, based on the models, what is the difference? The difference. So think about what the word difference means in terms of operations. Difference means subtraction. So what you're going to do is you're going to subtract 2,000 and 1,600, as that's the two numbers we found, and you're going to be left with 400. The answer is 400. And that's your final answer. So we go to question 3. The graph models the amount of money Haley is paid Y in dollars for working X hours at her job. Estimate Haley's hourly pay rate. Well, once again, luckily, one of our points is 0, 0. We love that. That makes our life so easy. So now we're going to look for a point that's perfectly on the line. And this is a little bit difficult with how grainy this is. So I'm going to say probably this point is. Though that's difficult to say, but that looks like the closest point to an intersection. And that point would be, going up from here, would be 5, comma, over here is 60. So now you're not going to believe it. We're going to do the same thing we did for the other ones. We're going to do our change in Y over our change in X. Our change in Y is going from 0 to 60. That's a difference of 60. Our change in X, we're going from 0 to 5. That's a difference of 5. 60 divided by 5 is 12. So you're going to assume $12 per hour. That's it. All right. A grocery store sells 2 pounds of apples for $4. Use the add arrow tool to graph the relationship between the cost of apples and their weight. So, this problem requires no math at all, really. Because you know that if you're buying no apples, it's going to be $0. So you know 0, 0 is a point. Okay? And it tells you 2 pounds of apples is $4. So just put that on the graph. 2 pounds of apples is $4. That crosses right here. And then you hit your add arrow tool and you draw an arrow like so. And that's it. Just use the numbers they give you. There's no point in figuring out a rate of change because you could just use the numbers they give you. Easy. Done. Okay. Next question. Roderick can water his lawn with a small hose or a large hose. The small hose pumps 15 gallons of water per minute. The large hose pumps water at twice the rate of the small hose. Use the add arrow tool to show the relationship between time and the gallons of water pumped by the large hose. So, we're working purely with the large hose here. Okay? The small hose is irrelevant. The only thing the small hose is here for is to tell us how fast the large hose goes. Okay? The large hose pumps water at twice the rate of the small. The small pumps 15 per minute. So all you're going to do is you're going to take 15 and you're going to double it. Okay? 15 times 2 is 30. So that means it is pumping 30 gallons per minute. Whoops. Per minute. So once again, like with all of our other graphs, if the hose isn't turned on, then the hose isn't pumping any water. So 0, 0 is once again a perfectly good point. So now our other point should be 30 gallons after 1 minute. So we're going to go to find 1, which is right here. And now we just got to find 30. So we have 20 here, we have 40 here. We could estimate that the number between this would be 30. So we're going to put a point right here. And then just like last time, we use our add arrow tool, draw an arrow, and that's it. Okay? Again, just use what the problem gives you. Okay? And if you can't use 0, 0, that's fine. So if it's 1 gallon in 30 minutes, that would mean that after 2 minutes, it would be an additional 30. That would be 60. So you just put another point at 260. Which I now realize my arrow's a little bit off, but, you know, it's fine. All right. A company has an old laser printer that prints pages at a constant rate, as shown on the graph. The company buys a new laser printer that prints the same number of pages in 1/3 as much time as its old printer. Use the add arrow tool to graph the relationship between the number of pages printed and time for the new printer. So here's how you have to flip your thinking. Okay. You have this point. This point is, whoops. This point is 20. And we have 4 and 8. The difference between those two would be 6. So this would be 20, 6. Okay? So, it says that the new laser printer can print the same amount of pages in 1/3 as much time as its old printer. Okay? And what you can look at is that if you wanted to divide, if you wanted to find out how long it would take to print 6 pages of paper, you would have to divide 20 by 3, which is a pain because 3 doesn't go perfectly into 20. You would get 6.66666, right? But you can do this the other way. Instead of dividing 20 by 3, you can instead flip this around and figure that in 20 seconds, it will print, the new printer will print 3 times the pages. What's 3 times the pages? 6 times 3 is 18. So still in our 20 seconds, we're going to print 18 pages now. Let's find where 18 would be. Well, here's 16, here's 20. The number between 16 and 20 would be 18. So you're going to keep going up here. Oh, my goodness. And you're going to go over here, and you're going to put a point right here. And then you're going to draw a line. Woo-hoo-hoo! That's a line. Now, I'd like to point out, you don't have to draw these lines that show where the point is. I'm doing that more for your reference so that you can see how I'm getting to these points. So when I look at the answer key for these, this answer key for this question says that the correct answer is any line that goes through the point 20, 18. So as long as your point goes through 20, 18, starting at 0, 0, you're good. Okay, it doesn't have to be pretty, just has to go through 0, 0 and 2018. Okay. Marisol, Timothy, and Zorian. What names? Each have a machine that purifies water. The two tables below show how much purified water Marisol's and Timothy's machines have produced at certain times after pouring water into the machine. And they give us two tables. Zorian's machine produces purified water at a constant rate that is faster than the rate for Marisol's machine and slower than the rate for Timothy's machine. What equation could represent the amount of purified water in ounces that Zorian's system produces after X hours? So we got to find two rates of change. We got to find the rate of change for Marisol's machine, and we got to find the rate of change for Timothy's machine. So here's how we're going to do that. We're going to compare their X's and their Y's. Okay, so let's look at time here, right? Here, we go from 2 to 3. That's a jump of 1. From 3 to 5 is a jump of 2. From 5 to 8 is a jump of 3. Now let's check the other side. From 12 to 18, that's a jump of 6. From 18 to 30, that's a jump of 12. From 30 to 48, that's a jump of 18. Okay? So your change in Y of 6 over your change of X of 1 would mean that this is pumping at 6 ounces per hour. Okay? And if you use the other numbers, change in Y of 12 over your change in X of 2, that still gives you 6, as does 18 over 3 give you 6. Okay, so this is constant. Let's go to Timothy's machine. 4 to 6, that's an increase of 2. 6 to 9 is an increase of 3. 36 to 54, that's an increase of 18. 54 to 81 is an increase of 27. So again, we're going to do our change in Y, with this being our Y, over our change in X, with this being our X. 18 over 2 is 9. So Marisol's machine is Y equals 6X, and Timothy's machine is Y equals 9X. Okay? And it says Zorian's machine is faster than Marisol's, but slower than Timothy's. So what number is between 6 and 9? Answer, 8. Has to be 8. Because it can't be 6, because that would match Marisol. Can't be 9, because that would match Timothy. And it can't be 15, because it has to be slower than Timothy. So 8's your only option. Okay. Whew. So that's going to wrap up this standard. I'll be back for another standard. Until then, good luck on your state test.